We introduce a new 3D puppetry system that allows users to quickly create 3D animations by performing with their own toys, props, and puppets. Our system tracks rigid puppets using the Kinect and then re-renders them in real time with 3D models in a virtual scene. Before using our system, puppeteers must upload puppets and create color models of their skin. First, the puppeteer scans a 3D model of a puppet using the Reconstruct Me software. Then he textures the model using the color information from the Kinect. Our system uses this model for both tracking and rendering purposes. Next, the puppeteer captures template images of each puppet. Our system initializes tracking using these images. Finally, the puppeteer creates a color model of his skin, which our system uses to filter the Kinect point cloud. During a performance, our system identifies all the puppets, finds their 60 poses, and then renders them in a virtual scene, all in real time. Our capture module consists of three main components: the puppet identifier, the point cloud segmenter, and the pose tracker. The puppet identifier determines how many physical puppets are visible, as well as their identities. It compares the SIFT features from the Kinect feed to the features in each of the stored template images to find the best matches. Those matches reveal the identities and the rough poses of the puppets. The point cloud segmenter filters the raw point cloud from the Kinect. It first removes the background and the puppeteer's skin, and then divides the resulting cloud among the puppets. It completes this step using the last known pose for each puppet. Next, our system determines the 60 pose for each puppet. It uses the ICP algorithm to align the Kinect point clouds with each puppet's stored model. Finally, our system uses those computed poses to render the puppets in a virtual scene. Our system offers several controls and effects. 60 camera controls allow the puppeteer to change the virtual view before, during, or after a performance. Puppeteers can also change the position and intensity of the virtual light for dramatic effects. And we include layered animations for stories involving more than two puppets. Here, the puppeteer first captured the police car's performance, and then played it back while performing with the fire truck and ambulance. This animation shows some basic features of our system, including 3D virtual sets and real-time tracking of multiple puppets. Note that at one point, the puppeteer's arm occludes the duck, but we don't lose tracking. This animation was created by a novice with no prior animation experience. Here, the puppeteer uses a semi-transparent rendering effect near the tracking boundary to give the duck a ghostly appearance. In this animation, the puppeteer made use of physics to push the toys into each other during crashes. In summary, our system provides a uniquely simple interface that allows even novices to quickly produce 3D animations. Please see our project website for source code and more example animations.